Today we will see how to design the microprocessor. So this is my circuit here right here. So I'll be going through a quick demonstration and then explaining some of the sub-circuits. I included a little reset button here so I can easily go back to the first instructions when I need it. So we have a clock right here and I'll just go start doing in the clock. So right now we are going through a list of instructions right here, and the first half of each instruction goes down this wire to the decoder, and the decoder tells the rest of the circuit what parts are activated, and the second half goes into the multiplexer right here. And so some of the instructions deal with the second half and they put them in a file to be used either in ALU or in the display. So let's see it happens right now. So some of the instructions, the most common ones, will put a number into one of the two registers in the file and then display it. So this first line right here, display the hello right here through the instruction. After that it started using some more numbers but this time putting in the ALU, and with the ALU it's able to deal different functions, in the case adding. So the first displayed these numbers, but then we're going to actually add them together using a add function in ALU. It does multiplications. After that there is not a multiplication function, but until multiplication is adding. So we are adding 3 to 3 together and put the 6 one of the register and then add that 3 to the get 9. So after that we have subtraction, and so we have already added in the hardware subtract line. So this line coming right around here, but this is still good doing from the first half of the test during the software subtract. And so 4 minus 3, have to accomplish that we use to complement, and the textbook actually explain how to do that with exclusive gate in OR in this case we have exclusive OR function as part of the ALU, and so by using that we are able to turn a positive 3 into negative 3 and then have 4 plus negative 3 to get 1. And then finally we have 4 minus 3 demonstrating the hardware thing. So I just go to right here right now and show it to line from the hardware subtractor right now. So I can go and I have right here, go into adder, and in here we have added a bunch of exclusive OR gates to the 4-bit adder so that it negates the second number, so all the B inputs as well as adds 1 into the far right side, the least significant bit. So it has a carry, an extra carry. So through these it turns the adder into a subtractor. So let's take a quick look at the other case. Here is my ALU using for function right here and multiplexer at the end. There is a clock right and enable to enable whether it is not changes the register, and we got the selectors down here to show which of these functions will be used. What else do we have? So that's ALU. With the hardware bit, we have this register file. It has uh, it has two words, 4 bits, so it's pretty simple. There's uh, two 4-bit registers. Each one is made up of 1-bit register. Obviously, it jumped into the right here for 1 bit and a 4-bit. Yeah, it's a pretty simple. Down here we have a kind of selector that chooses which one of the register is written to, although both have their output at any given time. I think I'm going a little long